Hello and welcome to CryptoverseXplorers. Today, we're diving into Ethereum 2.0, what you need to know. In this session, we'll explore the next big leap in one of the most influential blockchain platforms. From its initial concept to its potential impact, join us as we unravel Ethereum 2.0. Understanding Ethereum. To fully appreciate the significance of Ethereum 2.0, we first need to understand what Ethereum itself represents. Created by Vitalik Buterin and his team, Ethereum was launched in 2015 as a groundbreaking innovation in blockchain technology. While Bitcoin introduced blockchain as a means of creating a decentralized digital currency, Ethereum took this concept further. It wasn't just another cryptocurrency. Ethereum envisioned a broader use of blockchain for developing decentralized applications, dApps, and executing smart contracts. This opened up a realm of possibilities beyond mere financial transactions. Ethereum's unique contribution to the blockchain world lies in its programmability. This is primarily achieved through its native programming language, Solidity. Solidity allows developers to write custom smart contracts, which are self-executing contracts with the terms of the agreement directly written into lines of code. These smart contracts run on Ethereum's blockchain, enabling a wide range of applications, from decentralized finance, DeFi, to digital identity management. Ethereum's introduction of these capabilities marked a pivotal moment in the blockchain's evolution, transitioning it from a ledger of transactions to a platform for decentralized solutions and innovations. The need for Ethereum 2.0. As Ethereum's popularity surged, so did its challenges. The primary issue was scalability. The original Ethereum blockchain, running on a proof-of-work (POW) consensus mechanism, could handle only about 15 transactions per second. This limitation became increasingly apparent as more dApps and smart contracts were developed on the platform. High demand led to network congestion, resulting in slower transaction times and increased transaction fees, commonly referred to as gas fees. This scalability bottleneck was not just an inconvenience but a significant barrier to Ethereum's wider adoption and functionality. The demand for a more scalable solution became undeniable, especially with the burgeoning interest in DeFi applications and the growing complexity of smart contracts. Ethereum needed an upgrade that could handle increased demand and provide a more efficient, scalable, and sustainable platform. This necessity led to the conceptualization and development of Ethereum 2.0. Ethereum 2.0, or ETH2, is envisioned as a series of interconnected upgrades to the existing Ethereum network. The core objectives of these upgrades are threefold: improving scalability to handle more transactions, enhancing the network security to protect against potential attacks and vulnerabilities, and transitioning to a more energy-efficient consensus mechanism. Each of these goals addresses a critical need, setting the stage for Ethereum's next evolutionary phase. What is Ethereum 2.0? Ethereum 2.0, also known as ETH2 or Serenity, represents a significant evolution of the existing Ethereum blockchain. This upgrade is a comprehensive response to the challenges faced by the current Ethereum network, particularly in terms of scalability, security, and sustainability. Rather than creating a new blockchain from scratch, Ethereum 2.0 is a series of interconnected upgrades, each designed to improve specific aspects of the Ethereum network. One of the key features of Ethereum 2.0 is its shift from the current proof-of-work (POW) consensus mechanism to proof-of-stake (POS). This transition is a game-changer for Ethereum's sustainability, as POS significantly reduces the energy consumption associated with mining. In POW, miners compete to solve complex mathematical problems to validate transactions and create new blocks, a process that requires a substantial amount of computational power and energy. In contrast, POS relies on validators who are chosen to create new blocks based on the amount of cryptocurrency they hold and are willing to stake as collateral. This shift not only lowers energy consumption but also opens up the process of block validation to a broader range of participants. Another major goal of Ethereum 2.0 is to increase the network's transaction speed and capacity. The current Ethereum blockchain has limitations in handling a large number of transactions quickly and efficiently, leading to network congestion and high transaction fees. Ethereum 2.0 aims to solve these issues by implementing various technical improvements, thus making the network more scalable and capable of supporting a much larger volume of transactions. These upgrades are crucial in ensuring Ethereum's ability to support a wide range of applications and maintain its position as a leading platform for decentralized applications and smart contracts. The phases of Ethereum 2.0. The transition to Ethereum 2.0 is structured in multiple phases, each with specific objectives and functionalities. Phase 0, which was launched in December 2020, marked the beginning of this transition. In this phase, the beacon chain was introduced. The beacon chain is a new POS blockchain that runs parallel to the existing Ethereum blockchain. It serves as the backbone of the new POS consensus mechanism, laying the groundwork for future phases. Phase 1, the next step in the upgrade, is focused on implementing shard chains. Shard chains are a scalability solution that divides the network into smaller, parallel chains. Each shard chain can process its own transactions and smart contracts, which means that the overall network can process many more transactions simultaneously. This sharding significantly reduces the load on each node, making the network more efficient and scalable. Phase 1.5 is a crucial milestone in the Ethereum 2.0 roadmap. In this phase, the existing Ethereum mainnet, which still operates on POW, will merge with the beacon chain. This merge represents the official transition of Ethereum to a POS consensus mechanism. It's a critical step in reducing Ethereum's environmental footprint and improving its scalability and security. Finally, Phase 2 will build upon the earlier phases by introducing new functionalities and further improvements to the network. Although the specifics of Phase 2 are still being defined, it is expected to include features such as enhanced smart contract capabilities and increased network capacity. This final phase is aimed at fully realizing the vision of Ethereum 2.0 as a more scalable, secure, and sustainable platform. Proof of stake and the beacon chain. The transition to proof of stake, POS, marks a pivotal shift in Ethereum's evolution. POS stands as a more energy-efficient alternative to the proof-of-work (POW) mechanism that Ethereum, like Bitcoin, initially used. In POW, miners expend a significant amount of computational power and energy to validate transactions and mine new blocks. POS, however, eliminates the need for such intensive computational work. Validators in a POS system are chosen based on the amount of cryptocurrency they hold and are willing to stake. This staking process involves validators committing a portion of their Ether, ETH, as collateral to validate transactions. By staking their ETH, validators are incentivized to maintain network integrity, as dishonest behavior could lead to the loss of their staked assets. The beacon chain, a critical component introduced in Phase 0 of Ethereum 2.0, serves as the backbone of the new POS consensus mechanism. Launched in December 2020, the beacon chain runs parallel to the existing Ethereum blockchain. It introduces and manages the POS protocol, laying the groundwork for future phases. The beacon chain is responsible for registering validators, coordinating consensus among them, and managing the staking rewards and penalties. This chain is essential for the POS system to function correctly and securely. It represents a significant technological leap, paving the way for a more sustainable and efficient Ethereum network. Shard chains explained. Shard chains are a key feature in the Ethereum 2.0 upgrade, set to be implemented in Phase 1. They represent a fundamental change in how Ethereum's blockchain will be structured and processed. The concept of sharding involves splitting the Ethereum network into multiple parallel chains, known as shards. Each shard chain can process its own transactions and smart contracts independently. This means that the computational load is distributed across multiple chains rather than being concentrated on a single blockchain. By implementing shard chains, Ethereum 2.0 aims to significantly increase the network's capacity and transaction throughput. As each shard chain processes transactions independently, the overall network can handle many more transactions simultaneously. This parallel processing capability addresses one of Ethereum's most pressing issues: scalability. Shard chains are expected to alleviate network congestion, which in the past has led to slow transaction times and high gas fees. This scalability solution is not just about handling more transactions, it's about enhancing the network's capability to support a wider range of applications and a larger user base. Shard chains also represent a significant evolution in blockchain architecture. They bring a level of complexity and technological innovation aimed at making Ethereum more efficient and scalable. This development is crucial for the long-term success and adoption of Ethereum, especially as the demand for decentralized applications continues to grow. The introduction of shard chains in Ethereum 2.0 is a major step toward creating a more robust, scalable, and user-friendly blockchain platform. The merge and Phase 1.5. Phase 1.5, often referred to as the merge, is one of the most anticipated milestones in Ethereum's transition to Ethereum 2.0. This phase involves the merging of the existing Ethereum mainnet, which currently operates under the proof-of-work (POW) model, with the beacon chain, which operates under proof-of-stake (POS). The merge signifies a fundamental shift in Ethereum's operational mechanism. The transition to POS through the merge is set to address one of the most significant criticisms of the current Ethereum network: its substantial energy consumption due to power mining. Power requires miners to solve complex mathematical problems, consuming large amounts of electricity. POS, on the other hand, requires validators to stake their ETH to participate in the process of block validation, which is far less energy intensive. The merge, therefore, is expected to dramatically reduce Ethereum's carbon footprint, aligning it with the growing demand for sustainable and environmentally friendly technologies. Furthermore, the merge represents a pivotal moment in Ethereum's history, as it will mark the end of Ethereum as a purely POW blockchain, transitioning fully to a POS model. This change is expected to enhance the network's scalability and security while maintaining decentralization, a core ethos of Ethereum. Future prospects and Phase 2. Looking beyond the merge, Phase 2 of Ethereum 2.0, though still in the conceptual and development stages, promises further enhancements and capabilities for the Ethereum network. This phase is expected to introduce several key features, including state execution engines, which are set to provide a more efficient method for processing transactions and executing smart contracts. Additionally, Phase 2 aims to enhance the capabilities and user-friendliness of smart contracts, making them more versatile and accessible for developers. This phase is about fine-tuning the Ethereum network to better serve its diverse user base, from developers creating complex decentralized applications to users engaging with these applications. Phase 2 is also expected to focus on improving Ethereum's scalability and general performance. This includes potentially introducing features that streamline and optimize the way data is stored and accessed on the network. While details are still being finalized, the overarching goal of Phase 2 is to solidify Ethereum's position as a leading, innovative, and user-friendly blockchain platform. Implications for developers and investors. The evolution of Ethereum into Ethereum 2.0 carries significant implications for both developers and investors. For developers, Ethereum 2.0 promises to offer a more robust, scalable, and efficient platform for building and deploying decentralized applications (dApps). The improvements in scalability, speed, and functionality are expected to provide a more conducive environment for development, potentially leading to an influx of new and innovative dApps. For investors, Ethereum 2.0 introduces new opportunities, particularly in the realm of staking. With the shift to a POS consensus mechanism, investors can now participate directly in the network's security and consensus processes by staking their ETH. This not only contributes to the network's health but also provides investors with a potential source of passive income through staking rewards. However, the transition to Ethereum 2.0 also brings challenges. Developers and investors alike will need to adapt to the new system. For developers, this might involve learning new programming paradigms or adapting existing dApps to the upgraded network. For investors, understanding the nuances of staking and the implications of a POS-based network will be crucial. Despite these challenges, Ethereum 2.0 represents a significant step forward in the blockchain and cryptocurrency space, offering enhanced capabilities and opportunities for all participants in the ecosystem. Ethereum 2.0 represents a significant leap forward in blockchain technology. It addresses key issues while paving the way for a more sustainable, secure, and scalable blockchain ecosystem. As we move towards a more decentralized future, Ethereum 2.0 stands at the forefront of this transformation. Thank you for joining us in this deep dive into Ethereum 2.0 on CryptoverseXplorers. Don't forget to like, subscribe, and share your thoughts. Stay tuned for more insights into the evolving world of blockchain and cryptocurrency.